everybody, and welcome to the third video on solving exponential equations. In this video, we have a look at more complicated exponential equations, which would require some of the techniques that I learned earlier. So let us begin with the first one. We have number one, 5 times 2 to the power of x minus 2 to the power of x plus 1 is equal to 3. Now, in this one here, what our aim for exponential equations are all the time is to get the bases the same and then to solve for x. We can see that the 2 to the power of x, the exponential part, is in both terms over here. So we have to think about how to get that separate from everything else. Now, if you look at it carefully, you can see that it is in both of the terms on the left-hand side. So one of the things you can do is factorize. So maybe so that you can see it clearer, let's put in one more step. So 2x plus 1 by your exponential laws can be written as 2 to the power of x times 2 to the power of 1. So now you can clearly see that both of these have this 2x in common. So what we're going to do is we're going to factorize it out as a highest common factor, and what we're going to be left with is 5 minus 2. And that is equal to 3. So we can then simplify this. This is 2 to the power of x, 5 minus 2 is 3, and that's also equal to 3. We can divide both sides by 3 to get the x by 2 to the power of x by itself. And when we get that 2 to the power of x is equal to 1. Remembering more of our exponential laws, we remember that anything to the power of 0 is 1, including 2 to the power of 0. That way we make the bases the same, and then we can drop them and we get that x is equal to 0. Okay, so that was one example of how we can have a more complicated exponential equation. Let's have a look at another one. So now we've got 2 to the power of x minus 1 times 2 to the power of x plus 1 is equal to 5 minus 2 to the power of x. Again, we need to solve this, but the 2 to the power of x is all over the show. It's kind of difficult to make 2 to the power of x a subject. But if you think about your previous sections, what was one way to get rid of or make a more complicated equation simpler? It was the substitution method. We can see this 2 to the power of x being repeated in several places. So what we can say is let k equal to 2 to the power of x. Now if I do that and replace everywhere that we had 2x with k, we get that k minus 1 times k plus 1 is equal to 5 minus k. Now, what happens now is we've taken something that was fairly complicated into something we know how to solve. This here is a quadratic. Let's multiply it out. This here is the difference of two squares. So the product is k squared minus 1, and this is 5 minus k. With a quadratic, we need to take everything over. So it's k squared minus 1 minus 5 plus k. When we take everything over to one side, ordering it and putting it in order, we get k squared plus k minus 6 is equal to 0. How do we solve a quadratic equation? We have k plus 3 times k minus 2. That's how we're going to get plus k. So that means we have k plus 3 is equal to 0, which means k is equal to negative 3, or k minus 2 is equal to 0, which means that k is equal to 2. Now, we weren't solving for k. Our original equation was in terms of x, so let's do that resubstitution. So k is equal to 2 to the power of x, so replacing k with 2 to the power of x, we get 2 to the power of x is equal to negative 3, and on this side here we can do the same thing. So we get 2, so we're replacing 2 to the power of x with k, our original substitution is equal to 2. Now in this way, the first one here, there's no way that we can possibly get a negative answer from having a positive base. So here we're going to write no solution. You can try solving it, but there's no way to get a negative number from a positive base in our real numbers. Okay, this one here is a normal exponential equation. We want to make both the bases are same, so we can then drop the bases and have that x is equal to 1. So this one here, we've solved more complicated looking exponential equations, and the trick was to use other methods that we have learned earlier. If you are unfamiliar with any of the methods that we have used, specifically factorizing the k or substitution method and factorizing quadratic equations, please watch our previous videos so that this makes more sense.